Let's continue our calculation of the leading order contribution to the electric field when we're looking at a field point which is very far away from the source charges. Now, we calculated this in our last video, and we have the dipole moment, so we can rewrite that y component of the electric field in terms of the dipole moment p. That means we can get rid of our factor q. It's the dipole moment k, our constant p over r cubed. We have a 2a cubed, so there's a minus 1. There's a 2a in here times q, so we just have a 3y squared over r squared. And remember, in our result, r is equal to x squared plus y squared to the 1/2. And that's an expression for the x and y components of the electric field to leading order in our approximation. And this is what we call the dipole field. Now, our next step is we'd like to rewrite this in a traditional way using polar coordinates. So let me write a coordinate system again. We'll put plus q and minus q. Now, what's done traditionally is I'm going to introduce the vector r. And in polar coordinates in the plane, we have two angles r and theta. I can define them any way I want. We've often defined theta with respect to the positive x-axis, but in this case, I'm going to define theta with respect to the positive y-axis. And that's going to introduce r hat and theta hat. And our coordinate system now would show us that our y is adjacent to the angle, so it's r cosine theta, and our x here is opposite the angle, and so x is r sine theta. And so I can write the x component here in terms of polar coordinates. Notice x component, but the variables that we're describing the components, we still are using I hat and j hat here, are given by r and theta in the plane, and we have 3 kp. Now, x is r sine theta, and y is r cosine theta over r to the 5th. And now you can see explicitly that this goes like r cubed because of the factors sine theta and cosine theta are numbers between 0 and 1. And so that really shows explicitly that the x component falls off like 1 over r cubed. And the y component, that already, well, we'll see the same effect. We have 1 minus 3. And here we have r squared cosine squared theta over r squared. And so we have this is equal to kp over r cubed times 1 minus 3 cosine squared theta. And that is our y and x components of the fields written in terms of the polar coordinates in the plane. What we haven't done yet is to re-express these in terms of the unit vectors r hat and theta hat, and that will be our last step.